Hello everybody and welcome to the Creatrix YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we'll support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable EC student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code ANKITESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code ANKITESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code AnkitESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in this video I'll be starting a new topic, that is MOSFET. Okay, so first of all let us understand the full form of this MOSFET term. It means metal oxide semiconductor, okay, and FET means field effect transistor. Now what is this MOSFET and how does it work? Basically, this term metal oxide semiconductor refers to its construction. That is, when we are constructing the MOSFET, we will have three layers. First layer will be metal, the second one will be oxide, oxide means SiO2, and third one will be semiconductor or silicon. This metal is most of the times aluminium, or sometimes we can also use polysilicon. Polysilicon is nothing but a polymer of silicon which behaves as a conductor, and it has better bonding properties with silicon as compared to aluminium. That is, polysilicon can bind with silicon in a much better way than aluminium can be bound with silicon. And what about this field effect transistor? This field effect transistor means that this transistor will work on the basis of electric field. It is affected by electric field or field effect transistor. So this first term is related to construction and the second term is related to working. So on what basis it works? It works on the basis of electric field. Now when we have conductor, inside a conductor, electric field is 0. So electric field can only exist in insulator and semiconductor. Insulator and semiconductor are two materials which support electric field, but a conductor has 0 electric field. Now we want to generate electric field. We know that the potential difference is given as minus E dot dl. That means electric potential and electric field are related to each other. So we say that electric field is generated by means of voltage applied. Okay, by applying the voltage we generate an electric field. Now this electric field is responsible for the operation of MOSFET, and that is why it is called as a field effect transistor. Now how does this electric field affect the operation? Due to electric field, we change the width of channel. What is this channel? Channel is basically path of current conduction. The path through which the current flows is called as channel, and the width of that channel will be varied by varying the electric field. Now due to change in the width of channel, the resistance, if area or width of the channel increases, the resistance of channel reduces. If resistance reduces, the current increases. That means I is controlled by electric field, and this electric field is generated by voltage. So what happens? The current in this MOSFET is controlled by electric field or voltage. That is why this MOSFET is a voltage controlled current source. Okay, because voltage is a controlling parameter, and what it is controlling? It is controlling the current flow. So it is a type of dependent source, and what category of dependent source? Voltage controlled current source. Whereas when we talk about BJT, BJT is a current controlled current source, because in that IC is equal to beta IB. So by controlling the value of base current, we can control the collector current. So BJT is a current controlled current source, whereas MOSFET is a voltage controlled current source. Now in case of MOSFET, we have 3 terminals. Like BJT has 3 terminals, MOSFET also has 3 terminals. What 3 terminals are there? The 3 terminals are called as drain, source and gate. So the first terminal is called as source. The purpose of this source terminal is to inject the charge carriers. Okay, it injects the charge carriers, or it acts as a source of charge carrier. It is similar to ammeter terminal in BJT. In BJT, the source of charge carriers was ammeter. The second terminal is drain. Drain absorbs the charge carriers. Which charge carriers? Which are coming from source. The purpose of drain or the working of drain is similar to collector terminal in BJT. And the third terminal is called as the gate terminal. This is the control terminal. In what way it is the control terminal? It generates electric field to control current flow between source and drain. So basically the current will flow between source and drain, and that current will be controlled by means of this voltage or electric field generated by the gate terminal. So what happens? We apply the voltage at the gate terminal and it generates the electric field in order to control the current flow between the source and the drain. I told you the path of current flow is called as channel. So that means channel will be created between source and drain to let the current flow. Okay. So channel is always present between source and drain, and through the channel the current flows between source and drain, and that channel is controlled by gate. Now just under the gate terminal we have oxide. Oxide is SiO2. So this oxide SiO2 is an insulator. If you have connected an insulator at the gate terminal, the gate current will be 0. So gate does not inject any charge carriers, or gate does not flow any charge carrier, but it only generates the electric field. So gate current is always 0. That is why the input impedance is tending to infinity. The input impedance of MOSFET is very high because no current is flowing from the gate terminal. So if you take the ratio of voltage and current at the gate, you will get infinity. Okay. So that is the biggest advantage of MOSFET, that input impedance is infinite. The second thing is MOSFET has smaller size as compared to BJT. If MOSFET has smaller size as compared to BJT, it can be used in IC design. So in integrated circuits, MOSFET is more preferred choice as compared to your BJT because it has smaller size. But also at the same time, the voltage gain of MOSFET is less than the voltage gain of BJT. Means BJT acts as a better voltage amplifier as compared to a MOSFET. So MOSFET is different from BJT in so many ways. First way, it is a voltage controlled current source. Second, it has smaller size. Third, it has high input impedance. Fourth, it has lower voltage gain. So that is why MOSFET is mostly used in IC design due to its smaller size. And in this chapter, when we talk about MOSFET, we'll talk about two types of MOSFET. The first one is called as depletion type of MOSFET, and the second one is called as enhancement type of MOSFET. These are the two type of MOSFET that we'll be studying. Okay. So in this video, I'll tell you more about depletion type MOSFET and we'll cover enhancement type MOSFET later on. So if you see, this is the device structure of depletion type MOSFET. Since we have designed this structure in two-dimensional, so it is also called as planar technology. That is, MOSFET is using a planar technology, or it can be designed in two dimension. Is it fine? Now see, in MOSFET what happens? There are two types of MOSFET. I told depletion and enhancement type. Similarly, there are two more categories, N channel and P channel. What is channel? Channel is the path of current flow. If the path of current flow is N type, it is called as N channel. If it is P type, it is called as P channel. Is it fine? As simple as that. Current will flow between source and drain, and the path of current flow can be N type or P type, and that is how we decide N channel or P channel MOSFET. Now basically, MOSFET is a 4-terminal device. Okay. Now what are the 4 terminals? S, this is your source. D, this is your drain. G, this is your gate. And this also S, basically it is also written as B. B means body or substrate. So when you are constructing MOSFET, first we take a P-type substrate. So first what I'll do is, I'll take a P-type material that will act as a substrate. This is a P-type material. Then I will bombard group 5 impurity, or I'll use ion implantation to create N-type regions within this P-type material. That is, first I'll create source and drain. Now in depletion MOS, what is the special thing is that we do doping between these two regions. By doping we make it N-type, and this is called as channel. Since we are making N-type channel, it is called as N-channel MOSFET. Above this channel, we deposit oxide layer. This is your SiO2. And above this oxide layer, we deposit metal. So this is gate terminal. Okay. So see, metal, then oxide, then semiconductor. So that is why it is called as MOSFET, metal oxide semiconductor field effect transistor. Okay. So the width of SiO2 layer, width of oxide layer is between 1000 to 2000 angstrom. Because we want the layer to have sufficient width so that no current can flow from gate. Due to this oxide beneath the gate, current does not enter the gate terminal, or the current is always 0. Now due to this oxide layer, the input impedance of MOSFET is very high. I told in the previous slide also. Then it is a symmetrical device. What is meant by symmetrical device? That is, source and drain can be interchanged. That is, the drain terminal can be used as source and the source terminal can be used as a drain terminal. In BJT is not a symmetrical device. When we were studying BJT, recall that I told ammeter has the highest doping, collector has the lowest doping, and the size of collector is maximum to dissipate energy. That means in BJT, ammeter and collector are not identical to each other, but in a MOSFET, the source and the drain regions are identical, so they can be interchanged. MOSFET is a symmetrical device. Between gate and body, MOSFET acts as capacitor. Why it acts as capacitor? Because there are two terminals, gate and body, which are separated by a insulator, or you can say between gate and source also. If you think like this, between gate and source also, if you see, there is insulating layer. So what it will act as? It will act as capacitor, which we study in MOSFET in EDC. It is called as MOS capacitor. Okay. So that is why when we are designing integrated circuits, we are not designing capacitors separately, but we are using MOSFET itself as a capacitor. So that is a point to remember. In ICs, we don't design capacitors and resistors. We make use of transistor as resistor as well as a capacitor. Okay. So that is all about this depletion type MOSFET. What is the main thing about depletion type MOSFET? That by means of doping between source and drain, we are creating a channel. So channel is created by means of doping between source and the drain. Now let us understand the working. So what we want is, the source is the source of charge carriers. So electrons will always flow from source to the drain. Why electron? Because in n-type material we will have only electrons. So electrons will flow like this. That is why MOSFET is also called as unipolar device. Unipolar device because in MOSFET only either electrons or holes take part in conduction. Both will never take part in conduction. Either electrons or holes, they will take part in conduction. Whereas in BJT, both electrons and holes were a part of conduction. So it was bipolar device. Okay. And it is therefore also called as majority carrier device, because if you see, for n-type material, electrons are majority carriers and they are flowing from source to drain. So it is a majority carrier device. Now since electrons are going from source to drain, the current will go from drain to source. The current will go from drain to source. Now let us take some cases. Case 1. If gate to source voltage is 0 and drain to source voltage is always also 0. What I mean to say here is, why I am taking with respect to source as in BJT. In BJT I told you we will use one terminal as the common terminal. So here most of the time we use source as the common terminal. Just recall the amplifiers that we studied in BJT. What was the most common type of amplifier? The most common type of amplifier was common emitter amplifier. Now since emitter is replaced by source in MOSFET, the most common type of amplifier will be common source amplifier. Now VGS and VDS both are 0. Until you apply a potential difference between drain and source, until you apply a potential difference between drain and source, no charge carriers can flow, and you can say that drain to source current would be 0. This current means drain to source current. This is sometimes also referred as simply drain current would be 0. Is it fine? The channel is present, but in order to perform conduction, in order to have conduction, you have to apply potential difference. Now in case 2, suppose VGS is still 0, but we have applied VDS. If you have applied VDS, that means electrons will flow from low potential to high potential. Okay, electrons always go from low voltage to high voltage. So electrons will go from where? From source to drain. Why they are moving? They are moving because of potential difference or because of electric field. Electric field is always from positive terminal to negative terminal. So that means this is your drift current. In BJT I told you electrons were going from emitter to base because of diffusion. But here they are not going because of diffusion. Source and drain have equal doping. So they are moving from source to drain due to electric field. If the drain has light doping as compared to source, then electrons will go from high doping to low doping or high concentration to low concentration, which will be called as diffusion current. But here electrons are traveling between two regions of equal concentration due to electric field. That is why it is called as drift current. Now when VDS is 0, the drain to source current will be positive or current will go from drain to source. Okay. If you had applied, suppose if VDS was taken as negative, that means source would be positive and drain would be negative. Then electric field will be from source to drain. Electrons will then go from drain to source or current will go from source to drain. So IDS would be negative. That means due to this symmetrical device, you can have current flow from source to drain or from drain to source, or you can say MOSFET is a bidirectional device. Okay. In MOSFET, the current flow is allowed in both the direction, from drain to source or from source to drain. Now let us take another case, case 3. Case 3 is when VGS is negative and VDS is positive. Now when VGS is negative, that means you are applying negative voltage here. So this gate cannot inject any current due to oxide layer, right? No current can be injected from the gate terminal due to oxide. But this gate terminal can generate electric field. So this electric field will always be from positive to the negative terminal. This will be electric field due to gate. This is the electric field. Now we know electrons always travel in a direction opposite to electric field. So electrons will be going downwards. Okay. If electrons are going downwards, see, this was the source region. This was the drain region, right? In between source and drain, earlier we had a channel. This channel was n-type. If this channel was n-type, that means it had electrons. But now due to the electric field generated by gate terminal, these electrons are being pushed downwards. If these electrons are being pushed downwards, this channel will start to vanish and this channel will become like this. Here the channel vanishes. Channel means the path of current flow. but due to the voltage applied at the gate terminal, we are removing the electrons from the channel and the channel is getting vanished. Now one question that be coming to your mind is, why I have removed the channel from the drain side only and not from the source side? For that you have to understand one thing. Suppose the source is at 0 volt. I have applied negative voltage at the gate. Suppose -5. Okay. But we have applied positive voltage at the drain. Suppose 3 volt. Now what is the difference between gate and drain? The difference is 8 volt. Difference between gate and source, 5 volt. So where we have applied higher voltage? Higher voltage difference exists near the drain. So higher electric field will also exist near the drain. Right. Okay. Because wherever the voltage is higher, electric field will also be higher. So more electric field exists near the drain terminal. That is why the channel will be first removed from the drain terminal and then from the source. So channel will be starting to remove from the drain terminal first or before the source terminal. Okay. In this condition, when the entire channel vanishes, we say that the MOSFET is in pinch off. Pinch off means no channel remaining. Okay. If there is no channel remaining, the current would be 0. Are you getting my point? If you keep on increasing the gate voltage, the channel will keep on vanishing. And when the entire channel is removed, you can see that there will be no current flow between source and drain. And you will call that condition as pinch off. Okay. Is this fine? So now what we can do is we can draw the characteristics of MOSFET. Now there are two characteristics here. The first characteristic is called as output characteristics. In output characteristic, we plot the curve between ID and VDS, that is output current and output voltage. Okay. Now how to draw this curve? Understand this point very well. First of all, let me draw a reference curve when VGS is 0. So as you increase VDS, the current increases, and when VDS is 0, the current is 0. But after a certain time, the current will saturate. Okay. When VGS is 0, that is the second case I am drawing. This case. This one. The current is positive, but if you keep on increasing the value of VDS at a certain point, the current will saturate. Now if you apply negative voltage at VGS, if VGS is less than 0, the channel width reduces. If the channel width reduces, then what happens? The channel resistance is rho L by A. It will increase. If the channel resistance increases, the drain current will decrease. Okay. So when you apply negative value of VGS, the drain current will be less than the 0 value. Okay. So at a certain value of VGS, the entire channel will vanish, and that is called as pinch off. So in such a condition, the drain current would be 0. So here VGS is equal to the pinch off voltage, and this pinch off voltage is negative. Now suppose I apply positive voltage. What will happen in that case? See, if I apply positive voltage here at the gate, then electric field is away from the positive voltage. If electric field is away from the positive voltage, what is the direction of electrons? Electrons will move away opposite to the electric field or into the channel. Okay. So it means electrons enter the channel. When we are applying negative voltage, electrons are pushed away from the channel, and when we will apply positive voltage, electrons enter the channel, which means the width of the channel will increase. If width of the channel increases, the channel resistance will decrease. In that case, the drain current will increase. Okay. So if you apply positive voltage, then the drain current will be higher. Is it fine? So that is what I told earlier. That is, by applying the gate voltage, we are controlling the width of the channel or the resistance of the channel. Now these are the output characteristics. The other characteristics are the transfer characteristics. In MOSFET, we never draw input characteristics because in MOSFET the input current is 0. Due to oxide layer, there is no input current, so we can't draw the input characteristics. Now VGS can be negative as well as positive. These transfer characteristic is a curve between ID and VGS. That is output current versus the input voltage. Now the current at 0 gate to source voltage is called as IDSS or the saturation current, and the current at pinch off voltage is 0. This pinch off voltage is negative. So how does the current vary? The current varies like this. In the negative voltage region, it is called as depletion mode. Why we are calling it as depletion mode? Because by applying negative voltage, we are removing the channel or we are depleting the channel. If we are depleting the channel, it is called as depletion mode. But by applying positive voltage, you are increasing the channel width. It is called as enhancement mode. We are enhancing the channel. But most of the times, we will make use of only the depletion mode in depletion type of MOSFET. Is it fine? So what is enhancement mode? When we are applying positive gate voltage and we are increasing the width of channel, it is called as enhancement mode. When we are applying negative gate voltage and reducing the width of the channel, it is called as depletion mode. Okay. So let us move on. Now how to show depletion type MOSFET in a circuit? What is the representation? As we have seen, there are 4 terminals. What are the 4 terminals? The drain, the source and the body. Okay, this is the body terminal. This is the drain terminal. This is the source. What is the 4th terminal? Gate. Now this gap between this drain, source and gate represents the oxide layer, and the line connecting the drain and the source terminal, this represents the channel, this straight line. Now the body terminal is most of the times connected to the source, and that is why MOSFET will behave as a 3-terminal device. If body is shorted to source, then MOSFET behaves as 3-terminal device. Okay. Now, in order to identify between PMOS or NMOS or N-channel MOSFET and P-channel MOSFET, in N-channel we saw the substrate was P-type substrate. Okay. If it is a P-type substrate, current enters the P-type, so we will show this arrow. If it was a P-channel type of MOSFET, then we'll have N-type substrate. We know that the current should leave the N-type material. So when we will draw a P-channel type of MOSFET, this is gate, drain, source, the P-channel type of MOSFET will be like this. This is body. Okay. So the arrow will be coming out because in P-channel the body is N-type. So current leaves the body. In N-channel the current enters the body because it is P-type. Now let us understand what are the different regions of operation and what is the current voltage relationship within each region. Now see, the pinch off voltage was what was the significance of pinch off voltage? It is gate source voltage at which no channel exists or the current is zero. This in MOSFET is also called as threshold voltage. Okay. In JFET it is called as pinch off voltage, but in MOSFET we are calling it as the threshold voltage. Now when we were studying the characteristics, basically there are three regions of operation. When current is zero, it is called as cutoff. When current varies linearly with voltage, it is called as triode. I'll tell you the reason. Or ohmic region. Ohmic because of linear. And this is called as saturation. Like in BJT we had three regions: cutoff, saturation and active. Here active region is not there. Here we have ohmic or triode region. Okay. So now when we talk about threshold voltage, it is also the pinch off voltage or the voltage at which no channel will be existing or the drain current will become zero. So when we talk about the cutoff region, for cutoff region VGS is less than VT. VT is the pinch off voltage. That means if you see this characteristic in this region, that means if you apply a voltage more negative than the pinch off voltage, the drain current would be zero. This drain current would be zero. Okay. The next region is called as your triode or ohmic region. Okay. The next region is your triode or ohmic region. In this region, this VGS is greater than VT and the drain to source voltage VDS is less than equal to VGS plus mod VT. Why I am taking mod VT? Because VT is negative. This VGS will also be negative, right? So for triode region, VDS will be less than VGS plus mod of VT. If it is the case, then the drain current is given as 2K VGS minus VT into VDS minus VDS square by 2. Now why it is called as triode region? Because gate and drain both terminals are appearing in the current equation. Okay. So if both are available or both are basically observed in the current equation, that means MOSFET is acting as a 3-terminal device. Due to 3-terminal device, it is the triode or three terminals. Now what is this K? This K is mu n COX W by 2L. Now what are these things? Mu n is mobility of electron. COX is oxide capacitance, but its unit will be farad per centimeter square. W is channel width and L is channel length. Channel length is basically the distance between the source and the drain terminal. So these are the terms involved in this value of K. Okay, this K is sometimes also written as Kn into W by 2L, where this Kn is nothing but mu n Cox. Is it fine? Now when we talk about the third region, that is saturation region. In saturation region, your VGS is greater than or equal to the threshold voltage, and at the same time this drain to source voltage is also greater than VGS plus mod of VT. In that case, what happens is the drain current comes out to be K VGS plus mod VT whole square. Okay. And here also, since VT is negative, so negative, negative, positive, so you can also write it like this. Either you can write it VGS minus VT or VGS plus mod VT. Both things are same because VT is negative. Is it fine? So that is the drain current here. Now I showed you when VGS is 0, the drain current is called as the saturation current, IDSS. So IDSS is K mod VT square. That means K can be written as IDSS by mod VT square. In that manner, you can write drain current as IDSS by mod VT square VGS plus mod VT whole square. If you take mod VT square inside, it will be 1 plus VGS by mod VT square. Or you can also write it like this. Since VT is negative, mod of VT will be minus VT. This same equation is used in JFET. So that is the same equation that is used in depletion type MOSFET. Is it fine? So that means the current equation of depletion type MOSFET and JFET is exactly same, but in MOSFET it occurs in the saturation region. That is why the analysis of depletion type MOSFET is same as JFET, but it is not asked in the GATE exam. So if we summarize what we have learnt in this video, I have told you the construction and features of depletion MOS. Okay. Then we have seen working. How does a depletion type MOSFET works? Okay. We have also seen the differences of MOSFET with BJT. Okay, that we have seen. Other than this, what we have seen? We have seen the characteristics of depletion type MOSFET. And we have seen how do we represent a depletion type MOSFET. Later on, we have seen the operating region, that is when VGS is less than equal to VT. The drain current is 0. This is called as cutoff. VGS greater than VT. VDS less than VGS plus mod VT. Then drain current is 2K VGS plus mod VT VDS minus VDS square by 2. That was triode region. And the last one, VGS greater than VT and VDS also greater than VGS plus mod VT. Then drain current was K VGS plus mod VT whole square. That was called as saturation region. Okay, so that is what we have covered in this video. So you only have to understand how a depletion type MOSFET is constructed and how does it work. The question based on the equations of depletion MOS are very rarely asked. Okay, so they won't be asked. Is it fine? So that is all from this video. In the next video, we will consider other type of MOSFET, that is enhancement type of MOSFET.
I hope all of you have enjoyed the lecture that we were providing and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250. With code Ankit ESE it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that my friend, my personal Telegram channel also you can join, t.me/GateAIR1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.